So then we will go into the next part, which is pipelines. So pipelines is at section 39, which is technically where you guys are. Kind of quick thumbs up. You don't have to go into detail. Who has touched section 39? Okay, so I see a little thumbs up here and there. So I'm guessing most people haven't gone through section 39 yet, right? Okay. The only reason I ask that is because you'll see that the section is very, very small. I think there's literally 4 lessons in the whole thing, and one of them's an introduction and one of them's a recap. So like there's not much in the pipeline part. And I actually think that's, to be honest, a little bit of a shame because I think pipelines can be really useful in what you're doing. This is where we get introduced a lot to grid search. So just quick thumbs up. We haven't seen grid search before in other parts of the curriculum, right? Doesn't sound familiar. Okay, yeah. So I think most people haven't talked about grid search. So grid search will be something useful in pipelines. And I'll talk about that today. So I think I mentioned this before. I realized this is the first time I actually had a cohort go through pipelines. I don't know what ended up happening. I think people might just not have been able to attend and stuff like that. So this is kind of fun. So you guys can tell me a little bit how you guys like it. So we're gonna introduce some pipeline intro, and I will be upfront is that there is definitely some missing information in here I haven't quite finished. I'll tell you, for example, examples of using a pipeline. I do not have that filled out completely, but I do have some extra code that I've actually found from another GitHub repo that we can kind of talk about and walk through. But this is where pipelines can be super, super useful. So pipelines. So a pipeline basically it's like this really nice tool to use. It's not needed, but it definitely is one of those things that we could say, oh, a data pipeline. And basically data pipelines allow us to keep our code nice and neat, and it lets us kind of like work on sections of like the data science life process and work at it at a time, but also like at the same time, make it really flexible where we can just essentially pass the whole pipeline off to the next part, and we can adjust those things and basically use it for the full process of literally gathering the model, or start gathering the data, cleaning your data. You can even do it for analysis, all the way to like creating your model, like feature engineering, making predictions on the model, and actually fine tuning like hyperparameter search and stuff like that. So it's like a really useful tool to use. But like with all things, like I make this little joke here, you have to make sure it's useful and use it properly. If you build a pipeline that does not basically adhere to like what you're trying to do, it will not work well. In fact, it likely will not even like run properly. But the worst case scenario is not that it doesn't work properly. The worst case scenario is that it's working properly, or it looks like it's working properly, but in fact, you did something like wrong on the back end. So pipelines are really useful, but we'll kind of see like where they can also fail a little bit and where you have to be careful. But I think it's one thing that is like really big for production is that you can basically design a pipeline and say, okay, like build up the little parts of the whole data science lifecycle and pass it on to someone else. Or what you can do is come back to it and adjust those little parts. Okay. So, and think of a pipeline. This is where I would have a great graphic say, oh, look, a pipeline's like basically the flowing of data through the pipes, right? And each kind of pipe going through, it does some process and passes on to the next thing. And that's essentially what we're doing. And the beginning being that you're collecting the data all the way to the very end where like the data is processed, modeled, predicted to something useful, either to a new pipeline or to like a user or someone who can use that information. Okay, cool. So some advantages. So kind of going a little more detail of like what this is. So one is that it reduces complexity. So I kind of mentioned is that you can kind of focus on one part of the pipeline at a time. That can mean just debugging it, or it could just mean adjusting parts saying, hey, you know, like let's try to do this scaling, or let's try to do like this feature engineering aspect, or let's try this model, or let's try all of these different models. Instead of having to go from the very beginning, processing through like you think your notebook, like going through your whole notebook, running each part, and then doing it over, we can do it in sections essentially. And what's cool is that we can design the pipeline without ever seeing the data to begin with, if we know what the full process is supposed to look like. So this is again why it's super useful to actually deploy. So that kind of leads us to convenience, right? So you can summarize these like really fine details. Like imagine all that, like remember back, like I always say, back to the Mod 1 project when you guys had to go through the whole analysis and EDA and kind of go through these parts and then eventually find like, you know, what should be scaled, do a log transform. You can build this all into the pipeline and say, okay, these are the steps you're going to do regardless of the data that comes in, because I already kind of seen exact like what kind of data comes in, and you can do that and basically have it just pass through, and you can call like this part of your pipeline. It's like, oh, this is the transforming, part of the pipeline, basically like the, like say feature engineering part of your pipeline, or this is the modeling section of the pipeline. And all you have to do is take out that pipeline, adjust it however you want, put it back in, and you can continue on. So you can connect these pipelines really nice and easy. So you can focus on the big picture aspects of like your full process. They're also super flexible. So we'll talk about, I'll specifically talk about Scikit-learn because Scikit-learn's pipelines are just like the best thing ever. Like they are really flexible. They already have a lot of functionality and they're consistent and logical. But basically one thing we can do in here is that we can make our own like different types of, we'll talk about different parts of the pipeline, but we can create different estimators on that pipeline. We can actually create our own using object-oriented programming and design our own like transformers and predictors and all these different things. And what's really cool too, we can do some optimization techniques like grid search and random search, basically on finding the right tuning hyperparameters. Okay. And then our last one is actually a really big one. It also prevent mistakes. Essentially, it means that like we don't have to make as many mistakes. Since we're kind of looking at the bigger picture, it's easier to kind of see what the whole flow is. So we can focus on one section at a time. But also what's really important is that we can prevent data leakage. So data leakage, I might have mentioned this like way before, like especially when we talked about train test split and cross validation, is that basically we can keep our training set and our training set and our validation or testing set completely separate from each other. So what's nice that you can design the pipeline and say, okay, you're going to feed the data through here, and then it's going to output this part and say, okay, you train it through there. You basically do all the parts. I say, cool, this is my model that comes out. Let's go ahead and do it on the validation set, or let's go ahead and use like the scaling process on the testing set. Well, you can essentially just pass it on, like instead of the actual data, actually pass the pipeline over versus what's going to be changed. So I'll show an example of this when you can actually accidentally get leakage from grid search, where essentially you look at the full data set without realizing it. And then that can actually prevent or cause you to predict things that like, oh, with very, very high confidence, but it turns out you really shouldn't have because you've already seen the data before. So this is what we call a data leakage. So perfect analogy for pipelines and leakage. Okay, cool. So this is all the reasons why you should use pipelines and everything like that. This is where I say, hey, next time I will do this. It's basically, I was going to show you guys an example between like what something looks like without a pipeline versus like what it looks like with a pipeline. But we'll see parts of it and we'll see how to code this in a second with another part. But just know basically you can do all the steps that we're showing a pipeline. You can do that yourself. But building it in a pipeline is going to make it so much easier and just so much more convenient in the long run. Okay, so parts of a pipeline. Okay, and there's going to be a lot of text and stuff like that. So forgive me with all this stuff. But one thing basically is that I mentioned Scikit-learn, Sklearn has a built-in pipeline object, which is just the most beautiful thing in the world. It lets you be really flexible with what it is. So here's a documentation kind of going through, but I'm going to kind of go through the different parts that are kind of most important. So one thing I'm going to really emphasize is that all parts of the pipeline are going to be like an estimator. So an estimator, it turns out like transformer and predictor are going to be parts of an estimator. Okay, so just kind of going through that is that an estimator is just an object, right? So these are all objects. And it's an object in the pipeline that can take in data and estimate or learn something, it can estimate and learn on some parameters. So this actually makes it really general. So we can talk about things like a regression or a classification model. So think like linear regression and support vector machines, decision trees, random forests. Those are all estimators, but it also applies to things that transform the original data. So think of like, I put a scalar, that's not right. Standard scalar, it's probably what I was thinking of. So like think of like when we do scaling for your data. For example, if we transform and say, oh, we want to scale it down to min-max scaling, like a normalization, or standardized scaling, where basically we make the mean 0, right, and the standard deviation 1. Those are also estimators too, because they're taking in information and they're going to do something with that data. So they're learning from some data that you feed it. Okay. So what's cool is that in Sklearn's estimator object, they will always have a fit function, which kind of makes sense because an estimator always learns from the data. So we fit on that data. So all estimators can estimate/learn by calling the fit method, and just pass, and the one parameter it passes in is the data set. So every estimator will always have a .fit function, and you can feed in the data set. You can also pass in other parameters depending on what kind of estimator it is. And you can think of those other parameters as hyperparameters. They're the things that help the estimator to learn. So you can think of things like when we pass in like a support vector machine, or we saw dbScan. dbScan would be an estimator. We would fit it with information. We also can pass it hyperparameters and say, oh, we'll change this epsilon, change this min sample. And this is the thing that helps it learn, okay? So this is everything that's in the pipeline is gonna be an estimator, okay? And this leads us to a specific part, or specific type of estimator called a transformer. So a transformer, surprise, surprise, transforms data. So basically the idea here is that you take data in and you do something to it, and it creates a new transformation. So this can be really useful for creating new like features. So for example, think of like you want to combine, you know, in the data set, like your data frame, you want to combine two columns in a certain way, maybe you add them together. A transformer can add those together. You can do things, for example, say, hey, you know, my data set in here, let's say one of my data rows is just like a block of text. Like maybe someone like wrote like a text message or like a comment on a website. You can take that and say, okay, my transformer can take this part and count how many words there are, what the different verbs there are. So you can design your own transformer to decide. But a transformer can also just be simply like scaling. So for example, like if I want to say, okay, a transformer, I can say, all right, here's the data set, which is like, here's the min value, here's the max value, right? Or here's the data set, figure out what the min and max are, and then transform all the data so they fit within that min max. So a min max scaling from like -1 to like 1 or 0 to 1. Okay. So what's cool about the transformation is that, remember, all estimators have the fit function, right? So remember that we already have that, but we can actually just call a transform. So if there's nothing that we need to know about the data, we can just call .transform, and it'll basically take that data set in here, that parameter, and take that data and transform it to whatever we want. If you just want to add 1 to each data point in the data set, you could do that as a transformer. If you want to do something more complicated, you can do that too. But sometimes we actually want to take in data and say, okay, here's the data set, and you're going to transform it based on the data set. So like I mentioned, is like normalization when we take min-max. So in order to do a min-max scaling, we have to essentially say, okay, we do a .fit on the transformer and say, all right, fit based on this data set. Figure out what the minimum and the maximum are for the different columns. And then we're going to do a transform and say, okay, do a .transform. Now that it's fit, it's learned about what it should min-max. Go ahead and apply that transformation to all the data in that data set. Okay, so it's kind of nice. Like, well, that's a really common thing we do for transform. We think where we basically take in the data and then transform that same data. So we would have to do like your transform, let's say like, you know, standard scalar .fit data set, and then you have to do standard scalar .transform data set. You'd be like, this is really repetitive. What's cool is that we can actually call it fit transform method. So what this will do by default is it'll take basically say, all right, do .fit with that data set, and then do .transform with that data set. But I'll do it at once. What's kind of nice though is that if you do have a fit transform, especially with a transformer that someone created or like already put into like, you know, a package like standard scalar, it usually is optimized. So that way it does a really good job of figuring out how to transform it and figure out how to do the transformation and also do the transformation at the same time. So it's usually optimized. So usually if you have a choice, do fit transform over just fit and then .transform, just because this usually performs faster and better. At worst, it's the same speed as going .fit and then .transform. Okay. Does that make sense? Does everyone understand how a transformer fits in as an estimator? Thumbs up, thumbs down, sideways.
I had a question, Victor. What's
Yeah.
the difference between a pipeline and just, I don't know, building a bunch of functions that, you know, you can use to do the same thing? I mean, is there a difference?
Nope. The concept of a pipeline is essentially that it's a bunch of functions transforming or doing things to data, and it's passing on to the next part. So you can build your own like pipeline in the sense that like there's just a bunch of functions that like pass in one part, pass in the next part. The thing that makes something a pipeline over just like a bunch of functions that you write, or like what you guys have been doing in the past, is that it's a little more abstract, where you don't need to know exactly what the form of the data set is. You can essentially say, oh, apply this pipeline across all of this data, and it does all the steps that you would have had to, essentially write each part out.
Right, but I assume that like not every pipeline will be appropriate if it's like a wildly different data set, right?
True, that's right.
So like the Scikit-learn one, for example, like what is, I guess, what's a good use case of that pipeline? Is that just like really versatile that it can be used for most things?
Yeah, I would say it's really versatile in the sense that like any pipeline, and you should think of pipeline as more like a general kind of like concept, right? So like you can think of like a data frame as a sense of like encapsulation of data, but data itself is just really abstract. A pipeline is the same idea. It's like, oh, a pipeline essentially is just like taking a flow from the beginning to the end, or maybe just part of, whatever data science lifecycle part you're looking at or process you're looking at. But Scikit-learn just allows you to be really flexible in it. So it wouldn't necessarily be that like when is Scikit-learn's pipeline appropriate versus like, building your own. It's more like saying, oh, if you build a pipeline, whether that's with Scikit-learn or something else, it needs to be appropriate to the data set that you're looking at. So if you basically find that, hey, this data set performs really well by doing a support vector machine model on it, and you say, oh, we do these standardized scalars and stuff like this, and it performs really well. Well, that might not work well if the new data you come in may be completely different, but it doesn't perform well with support vector machines. So you would have to say, oh, I need a different pipeline. Or what you likely would do is say, let me just go ahead and change out this one part of the pipeline and replace it with a different kind of model or something else that's relevant to that kind of data set.
Right.
Does that make sense?
Yep. Sounds good.
Okay. Yeah. Yeah. And I think it's kind of confusing too, because pipeline, like in Scikit-learn, is like a class, like it is a specific class. And then there's also pipeline, the concept. So kind of know that those are separate, but usually, like to be honest, like Scikit-learn's pipeline is like really nice. I haven't seen too much. Yeah, I've seen people try to make their own stuff, which sometimes is just like easier just to do it. But like once you get used to using Scikit-learn's pipeline, it's like, oh, like this is amazing because you can make it so flexible and everything like that. Okay, good questions, Thomas. Okay, so but transformer and estimator, see the difference between those two? So remember, transformer is like a special case of an estimator. Okay. So the next one would be like a predictor. So we've actually been using predictors like this whole time whenever you do like linear regression. So remember, like when you do a linear regression like method from Scikit-learn, or if you do, decision tree, or so any regression classifier, those are predictors. Essentially, these things will learn from with the dot fit method. So you feed it the data set, so your training data, for example. And then once it learns from that, you can make predictions off a new data set. So like your testing or your validation data set. Okay. So these predictors are, again, another type of estimator because they're just taking in some information and learning from it, estimating from it. And then it just does a process where it can now make predictions off of that learning. So these are a couple extra methods that, wouldn't be in like every estimator. Obviously the predict method. So as you can probably guess, the predict method makes predictions of whatever data set you feed it. And note that this will make predictions after you train it, after you do a dot fit. Okay. You can also do a score, which is actually really convenient, where you can basically use that to evaluate how well it performs. So this score can be, for example, the accuracy score, but you can also modify this however you want and actually pull out the specific parts of, what's it called? That predictors, like whatever's relevant for that. For example, a regression predictor is going to be different from like a classification predictor on like what would be the score. Okay. Cool. So those are the three different parts. They're not too complicated, right? Like more or less basically the main things you're going to look at are things like transformers and predictors. You can also put other things in the pipeline itself where you can like use it, for example, in the pipeline, you can create a method that's going to acquire the data itself. But usually when we talk about pipelines as like a machine learning building process, we're talking about things that are estimators. Okay, cool. So this is where I say, okay, using a pipeline and everything. So I do have an example of this, but I actually think, I'm trying to think a little bit. So one thing I want to show is a little bit like how you can use a pipeline for a specific process that you guys can already do. So this is where we talk about grid search. So I'm going to kind of hop over to this grid search section. It loads up. Okay, so yeah, so grid search. So we haven't talked about grid search before, and this is where I'm kind of gonna emphasize a little bit like what this is. So essentially, one thing about machine learning in general is that it's really dependent on what hyperparameters you give it. And essentially the best way to know what those hyperparameters are, essentially just kind of keep tweaking it and see what happens. So this kind of comic right here kind of feels about right with a lot of the machine learning parts, where essentially you have the machine learning model and you essentially say, okay, like, you know, it's feed it a bunch of data. Does it work really well? And he says like, what if the answers are wrong? It's like, well, just give it a stir, you know, change out the hyperparameters and like see how well it performs after that. And that's more or less kind of like what this process looks like. And you can imagine is that like, do you know what those hyperparameters are? You might get a feel for it, but like they're kind of guessing at some points, right? Like you really don't know a lot of the times. So you can think of like hyperparameters like all these different dials and stuff like this. But you can think like how stressful this would be, like trying to adjust every single dial and say, oh, it performed this well. Wait, okay, it didn't perform this well in this one. Let me adjust this one, let me adjust this one. So you can imagine this would be like a huge pain, like trying to like keep track of all the different dials you changed. And also, we haven't gone too much into this, but a lot of models take like time to run. So like imagine like running this for like, you know, not just for 5 minutes, 10 minutes, but like half an hour to an hour for every model you do. And then all the different things you can adjust, right? And trying to figure out what the best thing to do is. It just would basically you'd be staring at a computer for the longest time, like waiting for the model to finish so you can run the next part and adjust it and see how well it performs. So this is where we automate stuff, right? So again, we make computers, I like to think of it as like we're automating the automation of learning. So that's kind of what grid search can be really useful. So essentially what we do with grid search, we give it a bunch of parameters. Like, all right, you're going to search over these hyperparameters. So imagine like for Scikit-learn, or not Scikit-learn, support vector machines, you have things like the kernel or like the C parameter, or like we just learned about DB-scan. We say, okay, you're going to search over epsilon of 0.1, epsilon of like 0.5, epsilon of like 1.0, epsilon of like 1.5, and then also just like, okay, like for, what's the other one? Min samples. You're going to try min samples of 4, min samples of 6, min samples of 8, min samples of 1, and it's going to try all the different combinations. So this is why you can think of it like a grid, where essentially we have all the grid of all the hyperparameters, and we say, okay, hyperparameter where epsilon is 0.1 and min samples is 2, and epsilon of 0.3 and min samples of 2. And so basically the idea is like we try to figure all that part out. So it makes it like really nice where we basically say, all right, do a grid search, just pass it on, let it figure it out. So this is what a basic grid search would look like. So you can kind of see here, I didn't import anything, but note that you can kind of look at the grid search here. Essentially what we do, we have a dictionary of parameters, okay? And so we define our classifier. So in this case, I have a classifier SV, so support vector machine, okay? And note that I didn't pass it any hyperparameters yet. Basically, this classifier is ready to go to be like either trained right now with the default hyperparameters or give its own hyperparameters. And so what's cool is that we can actually use this grid search object right here and say, okay, for this grid search, in this case classifier, we're going to pass in the original classifier, the support vector machine, and then a list of the parameters. So if you remember from support vector machines, you can pass in the hyperparameter of kernel, pass in the parameter of C, and you can basically say, all right, this list of hyperparameters, we can say, all right, use these ones. So in this case, you can see there's 2 for kernel and then 3 for C. So this would essentially have, you know, what's that? 6 different possibilities: linear with 1, linear with 10, linear with 50, or RBF with 1, RBF with 10, RBF with 50. Okay, does that make sense? I was kind of going through all of these parts. Yeah. And so again, the really cool thing is that note that I didn't train it yet. I basically say, all right, grid search, you are now a classifier, which is really subtle. Like when you think about this, I think this took me a long time, honestly, to kind of get my head wrapped around here. But remember, this is the classifier. And essentially what this grid search here is also returning a classifier. But this classifier is going to have all these different parameters. And this .fit function, hey, we learned about .fit, okay? .fit is going to use the train, the X train and then the Y train because it's supervised, right? We're basically going to use this to fit on this part. And note that's going to fit all of the models off the same data set. So it turns out this grid search here is actually part of the pipeline itself. Okay. So kind of a nice thing to kind of realize. So I'm going to show you where this can go wrong, where if you weren't careful, you basically create data leakage. So a bad grid search, one kind of subtle thing is that if you're not careful, especially if you're using something like cross-validation, you might be doing a grid search like this part, but actually have the scaling. So remember, our classifier, right, needs the data that's in here first. Well, the problem is if this data hasn't been scaled down, so if certain algorithms don't do well without scaling, we have to scale this data first. But if you're doing cross-validation, right, and you're doing multiple models, essentially what happens is like, well, you have to scale this part first, and it can actually cause leakage. So I'll show you an example of what this looks like. But remember, leakage is bad. We don't want our model to see anything about the testing or validation set. So note that I have this scalar here. So standard scalar, I think we've done something like this before. And we can do our scale data. It's just our scalar.fit transform. So imagine this X train here. So basically we're saying, okay, take the X train data and say, go ahead and transform the X train data based on, standard scalarization. So we set the mean to 0. So we subtract the mean from it, and then we make sure the standard deviation is going to be 1, right? The thing is, it's seeing all of X train data, right? So if we do cross-validation, remember cross-validation means that we split up our training data into training sets and validation sets, and we kind of take iteration. The problem is that because everything's been scaled over on all the whole data set, the whole training set, including the validation that will be in the cross-validation, it's now knows some information. Basically, it already knows a little bit like it's scaled over. Does that make sense to people? So the way you can kind of phrase, like, I think this might be kind of helpful is that if you say you have all of this data, and I'm going to use something really simple, like something like, okay, here's 3, here's like 2, and here's like, I don't know, let's say 10. Okay. The thing is like we're going to split in cross-validation. We're going to have essentially 3 and 2, and then 10 will be the testing. And then it'll be like 3 and 10, 2 will be the testing. And then, 10 and 2, and 3 will be test. Okay, like this, or I should say validation, right? Well, the thing is that if we scale this, like the min-max, right, we really should min-max just this part, right? So you can imagine like normalization, right? So this really should like say, okay, well, this will be 3 will be the highest, so this will be like transformed to, use a different color real quick. We can say, oh, this is going to be 1, and this will be like 2/3, like 0.6 or something like that. And then we transform this one, it's like, okay, this really should be, 10 is the highest, so just be 0.3, and this would be like 1, right? And then something similar here, we get 1 and 0.2, okay? So we should also always apply the same scaling to this part right here. So this 10, if we did this properly, this 10 should be at scale divided by 3. So divide by 3 here, that would be about like 3.3, right? So you can kind of see like how this would be adjusted. The problem is if we scaled all of it together, this whole thing will be transformed to 0.3 and 0.2. Right? And this bottom will be 1. The problem with that is that now it knows already, like by just looking at this information, it knows that it's scaled. It can kind of like figure out with this cross-validation, it already knows that there's a bigger number in this, this validation that it's never supposed to see. And this is where it can get very subtle. And this is where you say, well, is it really that big of a deal? Like, it doesn't seem like it would matter too much. The thing is with machine learning algorithms is that given enough information, sometimes it can learn things that you would not expect it to learn. So this can be actually a huge issue where we have this data leakage, and it might actually perform this cross-validation really well. And it turns out when you roll this out to your testing, you're outside of the validation, it's going to perform very poorly because basically it already saw the answers before it was able to, or when it was supposed to. So this is a really subtle one where this will work perfectly fine, but this will cause data leakage. So a way we can prevent this is, surprise, surprise, with pipelines. So this is actually the first time I'm actually showing you guys how to write this pipeline. But you can see here is that we're going to do the same thing. We're going to scale it, and then we're going to do a grid search over these hyperparameters. So what's cool is that this pipeline here, remember, pipelines are essentially just all estimators in this case. We can scale it first. This pipeline says, all right, go ahead and scale the information, and then go ahead and actually do the classification with support vector machines. So this pipeline encapsulates the standardized scalars and then performing the actual classification. And then we can pass this parameter sense. You can see here is that this doesn't matter too much by itself, but basically saying, do we scale with the mean versus scale without the mean? But you can see here, this is the part that I want to focus on. I really should just add this part right here, is that these parameters are the things that are going to be searched over here. So what's kind of cool is that this will actually take in now, say, okay, you're going to search over these parameters. We can pass the pipeline as like the parameter from the grid search. So grid search doesn't care. Grid search is like, cool, like you got a dot fit function, you got a dot predict function, awesome. Like I will go ahead and take that and go from there. So essentially we can replace this pipeline or this classifier with the pipeline that encapsulates the standard scalar. And that means that this data that will feed in here, this X train and Y train, will pass through this full pipeline and then be trained on the parameters versus saying scaling all of the information and then learning from there. So this helps prevent us from data, it's called data leakage. Okay. Should everyone see the difference between these two? Yeah. And the key part here is that this pipeline object right here from Scikit-learn basically has the dot predict and the dot fit functions or methods. So grid search is perfectly fine taking in a pipeline object. Okay. Any questions? I think I see some faces kind of going, what's going on here? So any questions you guys have? Yeah. Sound pretty good then? Thumbs up, thumbs down, sideways?
I think I just got to see it in action, some examples of it, which I could probably find in the curriculum.
Yes, so definitely the lab will be super useful in doing this. This is where, unfortunately, we're just out of time, so maybe I'll save this for next time too. I'll send out maybe this link. So I mentioned before hands-on machine learning with Scikit-learn and TensorFlow, the super long title book. The author, I can never pronounce his name, but the author has a GitHub repo. So I think I have it. No, I don't have it on here, but I'll send it to you guys for sure. Is that he has a GitHub repo where he shows a full data pipeline, so basically going from like end-to-end machine learning project. So you will be familiar with basically, getting the data. For example, this, is downloading the data into here, so you can see this function here. Now I'm just going to quickly go through it, but basically he goes through getting the data to discovering, like basically analyzing this information. So think like back to your first project, right? And then he says, okay, from this point, it's actually preparing for the machine learning algorithm. So basically getting the machine learning steps. And he actually shows a little bit of like, filling in missing data and stuff like that with something called like an imputer. But you can think of it like replacing missing data. And then he actually goes all the way to, where's my pipeline? Here we go. So you can actually see here is that he goes through this pipeline right here. Is that he creates this pipeline where basically he treats all the numerical information with a certain set of attributes, all the categorical information, and then he combines it into one full pipeline right here called a feature union. We haven't talked about that yet, but this basically combines those parts together. Basically, you can think of it like a pipe that takes in all like the numerical data, all the categorical data, and feeds it into, puts it together to make one large, data set. And that data set is this pipeline right here. And then it takes that pipeline and it's going to feed it into our linear regression. So you can see here, housing prepared, which was this guy right here. Oh, this is the old stuff. He's showing the pipeline going through. But basically he takes this information, feeds it into the regressor, in this case, the linear regression, so the predictor, and pushes that through here. And you can perform the what's it called, the machine learning aspect on there. So this is where basically like this part right here is really useful because now you don't have to like worry about this for like whatever model you're passing it to. You're like, hey, I just have to process it with this information, with this pipeline, and I can just pass that pipeline to a new model or to with new data sets. Okay. So I would suggest if you really want to see like what this looks like in the full kind of like going through it, this is a really good like just open free resource. If I'm being perfectly honest, is that I would strongly recommend this book. Was it Hands-on Machine Learning? I can never remember the whole title. What's it called? No. Here it is. Hands-on Machine Learning with Scikit-learn TensorFlow Concepts, Tools, and Techniques to Build Intelligent Systems. Second edition. Definitely get the second edition. It's got color. But unfortunately, it's not free, but it is worth every penny, in my opinion. It does a great job of explaining basically practical applications of machine learning, which you guys now know a lot of the algorithms that you would have to use here, and actually saying how this works in practice and kind of like deploying this out. So for example, you can see here this chapter of end-to-end machine learning and stuff like that. Is it free online? Ah, no. So you can see, I strongly suggest this book. I like it a lot, but of course, you know, each their own. I'm not going to tell you guys you need to buy this book. Buy this book. All right. And the author is really nice. Okay. I wish I knew how to pronounce his name. Does anyone speak French? I think it's French. Arion. I'm not gonna try. He says I've heard him say it like his own name, and I'm like, I can't. I'm so sorry. Like, I'm not gonna be able to reproduce his name. I need to practice it so I can recommend him. Anyway, I know I'm kind of over time, so maybe next time. I'm thinking maybe in the future we'll talk about pipelines, because I know the curriculum does have a lab on here, but I think it'd be useful for us to kind of go through that process and see, like, you know, what a pipeline looks like. Like we could literally just walk through this GitHub repo, which I'm just gonna go ahead and share it with you guys. Here is his repo for this specific book. So this repo is all the stuff in that repo, in his chapter book and stuff like that, with this information. So you can technically go through this part, but he doesn't have as many comments and stuff like that, so they really pair well with the book itself. But this is literally what I have cloned right here. It's this end-to-end project. So I'll send this out to you. I'll send it all to you guys right now, all that stuff. Okay. But yeah, any questions? I know, again, we're over time, so. Cool. All right, I'll go ahead and stop the recording here then.